In this video, we will solve the problem related to magnetic field intensity, and we need to find here magnetic field intensity at the origin. And from the given data, we can see that 4 conductors are arranged as a square. That is the square we are seeing in the diagram, and each side is of capital L meters we have, and its center is available at the origin. This is the origin. Okay, so this is L, this is also L, this is also L, this is also L. It is a square where the current I is passing in the anti-clockwise direction. That is what you can able to see. You can take clockwise also. Okay, because it was not mentioned. If the given figure is available as a part of the question, then you can take this one only. And here, according to right-handed coordinate system, this is x-axis, this is y-axis. So z-axis is coming out of the screen. Okay, positive z-axis is coming out of the screen. Now this is the situation. So we need to find the magnetic field intensity at the origin. So we have, from our basics, we have, when you have the finite conductor where the current I is passing DC current, and if the observation point is available in between Z1 and Z2. Okay, Z1 and Z2 are the lower end and upper end of the conductors, and if the Z, that means wherever you want to calculate the magnetic field intensity, that is observation point, if its height is in between Z1 and Z2, the H bar is given by I by 4 pi rho sine alpha 1 plus sine alpha 2 into phi cap. Okay, so here I, they did not give the value, so we can take I only, and rho we have to calculate from the capital L, and alpha 1, alpha 2 we have to calculate, and phi also we have to calculate, phi cap. But this is the formula can be applicable either any one of the conductors, either this one we can able to apply, either this one or this one or this one, because if this is the conductor, the observation point is here. So it is in between the lower end and upper end of the conductors. Okay. Or if you take this conductor, because of this conductor also, if you want to find the magnetic field at this particular point, this point is available in between the lower end and upper end of the conductor. Similarly, this one, similarly, this one. That means we have to calculate 4 magnetic field intensities due to the 4 conductors which are available as the sides of the square loop. Okay. And in all the cases, the same situation is there. That is, the observation point is in between the upper end and lower end of the conductors. Okay. So, and then one more thing we have to see, what is the direction. The phi cap is generally given by L cap cross rho cap. L cap is coming from the direction of the current, and rho cap is the perpendicular vector which is drawn from the current carrying conductor towards the observation point. Okay, so I will take to explain, I will take the conductors 1, 2, 3 and 4 like this. Okay, so in the first conductor case, the L cap is given in the direction of y, positive y. This is the current direction, so L cap is given by positive y cap. Okay, then rho cap is it is away from the conductor, so like this we have to take towards the origin. Okay, so in which direction it is available, rho cap? It is in the negative x direction. So by considering these two, I can write now L cap is y cap. It is in cross product with minus x cap. So what will get? Minus y cap cross x cap is the minus z cap. That means you will get positive z cap. This can also be understood by using the right hand thumb rule. You need to keep your right hand in the direction of the current in the conductor. Then what are the direction of your 4 fingers of the right hand at the observation point? These are coming out of the screen. That means these are traveling in the positive z direction. That is what we got. And same thing you can able to check for the remaining conductors also. So if you keep your right hand thumb in the direction of the current for the second conductor, that is in the negative x direction, then how your right hand 4 fingers are representing at the origin means these are coming from the negative z axis to positive z axis. So for the second conductor also it is the positive z axis only. Similarly, you can able to check for the third conductor and fourth conductor. For these also, the resultant magnetic field intensity will be available in the positive z direction only. Okay, so from the mathematical way also we can able to prove this is for the first conductor actually. So this is for first conductor. Now I'm going to take the second conductor. In case of the second conductor, the current is traveling in the negative y direction. You can able to observe from the figure. It is in cross product with the unit vector rho cap will be available downwards. From the conductor, you have to go away towards the observation point. That means it is in the negative y direction. Okay, so the current is traveling in the negative x direction. It is in cross product with it is traveling in the rho cap is available in the negative y direction. So this will give positive z cap only. Then for the third conductor, we can take the current is passing in the negative y direction. Okay, then the perpendicular line, that is rho cap, will be available in the positive x direction. Okay, this is again positive z cap only. Then for the fourth conductor, the current is traveling in the positive x direction, and the perpendicular we can take in the positive y direction, that will be in the positive z direction only. So these are the four different 5 directions I have calculated to calculate for h bars. Okay, then what about sin alpha 1 and sin alpha 2? So if you observe this one very carefully, this is the square we have, this is observation point, and in the square here we have 90 degrees, here also 90 degrees, 90 degrees, 90 degrees, but we will get the angles like this. The angle made by this perpendicular with the lines joining the observation point with the lower end and upper end, if you take, this is alpha 1, this is alpha 2. Because it is 90, in all the cases we will be having alpha 1 and alpha 2 are 45 degrees only. Okay, so this is 45, this is 45, this is 45, this is 45, this is also 45. So like this we'll get. Okay, so now I'm going to write first H1 bar. It is a magnetic field intensity at observation point due to the first conductor. So according to the formula, I by 4 pi rho. Rho is nothing but the distance between observation point and the conductor. This is L by 2. For the second conductor also it is L by 2, it is L by 2, it is L by 2. So I will take it is L by 2. Like this I can take. Okay. Then sin alpha 1 is a sin of 45, that is 1 by root 2. Sin alpha 2 is also sin 45, that is 1 by root 2. And phi cap already we got, it is the plus z cap. So it is only first magnetic field intensity. So what did we get here? 2I by 4 pi L. It is 2 by root 2, that is root 2 into z cap. It is a magnetic field intensity due to any one of the vectors, you will get the same thing. So now total magnetic field intensity is equal to h1 bar plus h2 bar plus h3 bar plus h4 bar. It is equal to 4 into h1 bar, that is equal to 4 into 2I by 4 pi L into root 2 into z cap. So 4 will be cancelled. Finally we got I into 2 root 2 by pi L into z cap. This is the answer.